All right. We have another problem here for arc length. This one will be a little bit easier. We're going to have to remember some trigonometric substitutions, but other than that, the simplification of the integral will be much easier. We're given a 0 to 5 interval, so start off with that. And we are tasked with finding the derivative of this function. So let's do that. X is equal to, let's see, so we're going to have to do the chain rule here. So we have negative 2x over 2 square root of 25 minus x squared. And we have 2's cancel. That equals negative x over square root of 25 minus x squared. That is our f prime of x. And now we are left with squaring it. So let's do that next. Negative x over 25 minus x squared. Square root that, square that gives us a positive x squared. 25 minus x squared. Now we can easily put this into our integral. Integral from 0 to 5, square root 1 plus this expression. We want to add this 1 to this expression. So we're going to make the denominator 25 minus x squared over 25 minus x squared. It's a 27. Add that to our expression here. Cancels out x's, gives us square root of 25 over 25 minus x squared, which simplifies to 5. Square root of 25 is 5 over square root of 25 minus x squared. That dx. That is our L integral here for part 1. Now we need to solve it via substitution. So we want to let x equals 5 sine theta. Take the derivative of that. So dx is equal to 5 cosine theta d theta. So we can rewrite our integral L integral with our new bounds 0 to pi over 2. We have 5. That's where we start using our integral. Oh, pardon me. You got an email. But we're going to use our trig substitution of 25 minus 25 sine squared theta, because that's where we have x squared, times we have our dx over here. So 5 cosine theta d theta. Take constants out. We have a 25 out in front of here. I think so that 5 and the other 5. Our integral still with the same bounds, 0 to pi over 2. This time we have cosine theta over square root of 25. We can factor out 25. 1 minus sine squared. This should look familiar. 1 minus sine squared. That is equivalent to another trigonometric expression, d theta. I'm going to apply that. We still have our 25 out in front. Integral from 0 to pi over 2. This 1 minus sine squared is equivalent to cosine squared. So we will run out on that. We will now write cosine theta over square root of 25 cosine squared theta. And now we have some 2 perfect squares over here. D theta. And before we know it, we just have 5 cosine theta over 5 cosine theta. Boom. It's just 1 over 5. 25 integral pi over 2 is 1 of 5 d theta. And that is simply, take that constant out once again. That's 5 integral 0 to pi over 2 d theta. That is theta from pi over 2 to 0, which is just pi over 2 times our constant, which is just 5, which is 5 pi over 2, and that is our arc length in exact terms.